The revisit is not possible. It's a mechanical scanning, which means inertia comes into the play. So there is a chance for people to migrate from this type of mechanical scanning to electronic scanning, and thereby it is known as AESA, that is aperture. It is an active electronically scanned antennas. That's how it is came into the picture. So in our country also, we started our journey in the 80s with the Aero aircraft being modified for the purpose of having a rotodome. Means a dome will be there, which is aerodynamically streamlined, and inside what you can see in your right side, an antenna which is having an elliptical aperture is kept, and which is a primary radar antenna. At the back of it, there was a secondary surveillance radar antenna also. What you are seeing, the antenna being mounted on top of the outdoor test range where it is being tested, and what you are seeing below that is the place where in HIL it is getting ready for mounting onto the Aero aircraft. However, the journey of this system, though the phase 1 was only a study phase in 80s, in 90s this airborne surveillance platform, none other than ASP, with an Aero started. It tragically ended in 1999 with a crash. So theoretically, the worldwide, there were systems with the mechanical scanning, which you can see 3 of them, American AVAX, as well as E2 and E3. In addition to that, Russian systems are also there available. While in the other side, early 2000 onwards, started with by Ericsson of Sweden, what is known as ERI. That has got electronic scanning. What you can see is the flat antenna without any dome fitted onto a smaller aircraft, could see on either side plus minus 60 degrees. That means out of 360 degrees, they can cover up to about 240 degrees, slightly stretch even up to about 300 degrees. That's a maximum possible with those aircrafts. But then the technology is entirely different. There is no electronic, there is no mechanical scanning, but it's a totally electronic scanning. But if you do require a 360 degrees coverage, you must go with a minimum of 3 such antennas to cover the entire 360 degrees, or you can even use 4 antennas also. So the advantage of ASA is basically to get inertia free. That means you don't have to have a mechanical rotation, which is really going to make your scanning or searching operation much longer, particularly when you're looking at a target which is coming at far off distance. You may have a revisit much later because the antenna has to make one complete rotation, while the ASA, that is active electronically scanned arrays, can probably revisit any number of times in a fraction of a second for us to conclude the presence or absence of the target right in the far off distance. Thereby, you are able to manage the energy given to you very effectively on those areas, whichever you like. In addition to that, in the event of failure, a single transmitter failure in the mechanical system would have probably stopped the total operation. While here, n number of TR modules, what we call it is a TR is nothing but the transmit receive modules, can probably stop working. In spite of that, we will have what is called graceful degradation. Obviously, the performance enhancement can be there because you may not be unnecessarily wasting your energy all the direction. However, you will spend more time and more energy on the direction of your interest. So going back to the TR module specific, there is a small equipment or a sort of a unit which contains the final transmitting power. If not in megawatt, it is generally in watts, followed by also it will have an LND. That is the transmit side, simple, smaller wattage level, that is hundreds of watt level transmitter, and the very sensitive receiver, or both are there in a unit. If you can keep them together, multiple of them, then you call it as a sometime transmit receive multi-module. That's what we are calling here DRMM. In this particular example, we have used 8 of them together so that we could have a thermal management effectively distributedly created. Because we are not having a single transmission, the power is getting probably amplified in more than one place. Naturally, the heat source is not going to be concentrated in one place. So the thermal management is excellent in these cases. In addition, this is precisely using what is called gallium arsenide technology. And further, we have gone ahead with the gallium nitride technology also. These are all the solid state amplifier devices having got an efficiency of 30 to 50% efficient. What is the advantage of the primary radar having ASA is, as you can see that there are scanning which are not necessarily sequence. You can go in any random sequence and have a revisit on the place of your choice and your interest. When you look at a threat, the threat is to be absorbed again and again till we confirm ourselves that the threat is a real threat or otherwise. So naturally, we have got an ability now with the ASA to have a relook on the targets any number of times. In addition to that, you can enslave your secondary surveillance radar also to the same place to not only identify but also to classify whether it is a threat of what nature also can be classified using the combination of primary and secondary surveillance radar. The range part of it, some numbers are given here. That is immaterial because as long as the aperture as well as the power is managed, the power aperture product gives the range. You can always extract by looking in some direction for a longer period, much longer range than what is indicated. The total system was probably how to be combined effort of several organizations even within DRDO. CAPS is a nodal agency which has taken the responsibility of the platform, its modifications, its wiring, and so many other aspects. In addition to that, it has also taken the complete secondary surveillance radar, mission communication system, mission system computer, and the operator workstation. In addition to that, the primary radar has got a very critical element, which is nothing but that antenna unit, which is on the top of it, which we call it as active antenna array unit, AAAU, and it contains the power supply, radiating element, as well as the entire TR modules. So naturally, this also need to be cooled and also need to be powered. Entire this responsibility is taken by the nodal agency called Center for Airborne Systems, while the rest of the part of radar, 2 more elements like signal processing and data processing, as well as the exciter was done by another organization called LRD. Likewise, communication by DRDO, CSM by DLRL Hyderabad, and ESM and SPS by DARE. All these units are different labs of DRDO. When we compare the system where we are in terms of performance, obviously the active array aperture radar, it is like any other systems. What is available at that point of time in Brazil, Greece, and Mexico. And compared to that, you can see that there are several places we are on the higher. Particularly in the case of active aperture radar, the elevation scanning is not there in the other system while we have introduced in this system. We also got a KU band SATCOM terminal. The reason being, in the event when the aircraft is operating at a range which is beyond the line of sight for the other data link, you can always continue to communicate wherever you are back to your station through satellite. Also, one unique thing in the aircraft itself is IFR, in-flight refueling system, which is not at all existing in any of the Embraer aircraft for that matter till today. And also in the AWACS, it is very essential because you do get additional time of flying. Obviously, because you are having air refueling, you must have some extra seats also. The entire internal is nicely ergonomically designed with the 5 operator stations and 5 rest crew seats, and all the other electronics is nicely packed in a rack form, whereby you cannot see internally any cable or any other hanging things. You will see like any other passenger aircraft, nicely, completely covered, packed nicely in that system. It also gives you a very good advantage of noise reduction. Thereby, the personnel working inside has got a comfortable time for working for long periods of serious work. It has got additional 4 tanks of fuel inside, in addition to the wing tanks, to get that endurance extended for a longer period. In addition to the interior, externally, if you look at it, there are a huge number of antennas. Some of them are small. You may not be able to visibly see it, but there are so many sensors out there. The aircraft per se has got about 29 or so sensors, whereas this system has added so many of them. As a consequence, nearly about 80 sensors all over the aircraft is there. The challenge here is, what do we do when we have too many antennas and too many sensors all around the aircraft? How do we avoid the mutual coupling or the interference from one to the other? It could be possible only in case we have 3 things: space, frequency, and time. When I said space, that means if I want one antenna to not linger or communicate with respect to the another antenna, obviously we have to separate them as far as possible. With the given small aircraft, there is a limitation on that. You cannot indefinitely will keep them separate. So there is a limitation. So then what we do is, we try and exploit the frequency, that means the spectrum. When you are operating one radio in one frequency, we try to use the entirely different frequency or far off frequency for the next radio. But then also you got 7 radios simultaneously have to work. Naturally, you have to have a lot more to be done. The last point is time. When we are operating, let us say, radar, when it is pumping huge amount of power, there is always a possibility a receiver in the ESM side may get saturated. So because of the huge power being coming from that radar transmission, so it is possible for us to give a gap or put a notch filter to avoid those areas of frequencies. Whereby doing this, all the 3 combination, we need to take this challenge, and it was indeed a problem. Initially, we had an issue, the aircraft operation. In the height, it used to have some wrong indication, which was wonderfully solved through using a nice filters in the entire operation. Having done this aircraft modification, interior, exterior, the major component, which is probably very critical in this system, is the AAAU, or none other than active antenna array unit, which goes externally. So unlike any other conventional radar antenna where enough of energy would have been spent on designing the antenna per se for its performance as a pattern or a side lobe, or for that matter gain. In this case, yet another dimension has to be looked into. First of all, it has to be aerodynamically very streamlined, because it is being an external unit, it is likely to give a drag. Naturally, the aerodynamics has to be taken into account, and the internal aerodynamics also to be taken into account, because we are trying to probably save the energy for cooling, or for that matter the heat removal, by simply using the normal flow of air as the aircraft flies for cooling the electronics, which is a very critical system. Likewise, we have got a radome to be tackled, which has to have the complete transparency as far as the microwave is concerned, but at the same time should have a rigidity enough to protect the antenna. And there are a good number of softwares are there. It should not get corrupted, and there are good number of tiny, very small electronics is there. It should not get burnt. So all these things has to be taken into account in terms of design. Next is mechanically, it is going to get loaded like any other aircraft. Not only the static strength, but also the dynamic load coming from the air load need to be taken into account. When the aircraft landing, the shock and other impact, probably for a rough landing, it may have to take into account much more amount of, impact. In addition to that, there's going to be a continuous vibration which need to be taken care of. Likewise, the new things are in the case of environment, rain, as well as lightning and erosion. These are all not necessary for every other antenna we worry for. Whereas in this case, they are the most important, particularly when there is a lightning. If not direct effect, there could be a possibility of indirect effect where the electronics probably can malfunction or totally get corrupted, including the software can happen the same thing. So the care must be taken to see that even under lightning condition, there is no damage happens except could be a small instantaneous glitch is allowed in the system. So the interior, if you look at it, the air goes from the inlet and takes a turn to the down. This is specifically done to ensure the rainwater that goes inside cannot go into the electronics but can go only to the downside. As the particles of the water are going to be heavier, they will not take up to the top, whereas the air alone will go for cooling. And there is a trap for the rainwaters and they get collected and it gets removed. So that is the way of protection from the rain or rainwater soaking directly. However, they are all made in such a way that some amount of spraying of air will not make any difference to the electronics. In addition to that, as the air traverses, it is having a tendency to go towards the end and get exited through the few TR modules which are kept at the end of the entire array. But the design has to be such that we ensure each and every TR module, right from the beginning till the end, it is able to cool in appropriate way. The bottom portions are the design details shown. The hotspots are given to you and how their hotspots are well within the permissible limits of the operating temperature of the elements or the electronics used. In addition to that, in order to get the maintenance done, we have made a wonderful way of removing a particular TR module. Not necessarily the entire antenna need to be opened. That's a very, very important aspect which is a patented item. Next. We also made use of the entire antenna in a very effective way to ensure that the structural rigidity comes out of the even antenna also. Antenna is nothing but a slotted array which radiates the S-band, whatever the frequency that we are assigning. So it is a basically metallic body. The metallic body given us two advantage. That's why we call it as one of the innovation. One is that it is giving a rigidity for the entire antenna in terms of fluxing and so many other structural point of view. In addition to that, it is also giving a sort of a Faraday cage for the complete electronics inside. So that is the reason why we could be able to achieve very good amount of shielding when there is a lightning effect. We have tested this antenna against the simulated lightning and absolutely no problem for the electronics with this. The actual antenna being tested for various conditions, you could see the slots because the initial or the top layer of the radome is removed in this case. We also could see two different type of slots. We have got one for the primary radar, the other one is for secondary surveillance radar. And the last but not the least is the structure is made out of this metallic body, which is what has given us that advantage to have sufficient strength or rigidity as well as the property to protect or shield the electronics inside. The most important aspect is the radome. The radome is supposed to give a protection for the electronics and the antenna. At the same time, it is also supposed to be a transparent. The line, what is in the plot, what we are seeing around 0.3 dB loss, and the straight line is the loss that what we are getting. For various scan angles, when the antenna is scanning at a different angle, if you have gone for a separate sandwich type of radome, we could have gone ahead with a slightly more loss. In addition to that, sort of a vary with respect to the angle of direction in which that we are looking the antenna beam, the loss also would have got changed. Whereas you could see here, simply flat and also lower level of attenuation as far as the radome is concerned. And it is completely tested for all the properties and it is satisfied totally. In addition to that, the peculiarity of the total system is, like any other aircraft, this being an external item has to go through what is called the bird strike test. Unless otherwise it passes the bird strike test, we cannot use it as an external body. So we have gone through the testing and then completely satisfied. You also see one figure showing the lightning striking at a mock-up, a smaller version of the antenna being done, and that is completely satisfied. Likewise, we also do the vibration test. That is also completely satisfied as an individual and as well as a group. The final testing and evaluation need to be certified by not only by our own inspection and certification agency. This being getting on top of the aircraft, which is nothing but the Brazilian's Embraer 145 aircraft, we need to satisfy them. Their inspectors were present here. We did the static strength test at NAL with a very good amount of tolerance. It could meet that. The problem here is if you have done very rugged or very over design, I'm sure all the tests it will meet, still nothing will happen. But if you have done a flimsy design, it will break even before we conduct few critical tests. But I was told by the Brazilians themselves, our design is excellent in the sense it was very, very critically designed and thereby it is optimum for the usage. Next. In addition to the structural aspect, the electronic, when you look at it, what you saw, the TR module is only generating the power. The power need to reach the none other than the antenna element themselves. Unlike the world has a sort of a system where there is no electronic scanning in elevation, only azimuthal scanning is covered. Here we have taken the responsibility of creating, including the electronic scanning in elevation. That is how the number of cables are much, much higher here. Equivalent about 2 kilometers of RF cables are utilized to probably power in elevation 8 element, and that gives us a sort of a scanning capability. Even in the steady state of flying, when there is a roll of 1 to 2 degrees, the scanning will take care of and keep the beam right on the target even at the low flying stage. Another point is very important to be looked at is the what is called water stagnation, or the place where the ice segregation can happen. When the ice is formed, it will break after some time, and that piece, if it happens to go to the engine, this aircraft having a rear engine, there is a possibility it can create a problem in the engine failure. In order to avoid that, we were given a constraint of not more than 600 grams any piece of ice that breaks and falls. So that is a constraint. The aircraft per se, it is certified for 425. That means it is having all icing protection. But then the additional equipment, like for instance, air-to-air refueling probe, or for that matter, AAAU, that is the antenna unit on the top, or the radome for the SATCOM, all these things are a new addition. They ought to be tested, they ought to be evaluated for where the ice can probably form. We know very well that ice formation can form and will form in those places where the velocity of the water particle or the moving air is brought to zero. So you can see that red spots or the bright spots shows the places where the ice can be formed and that need to be nullified. That is what the design has to go through. We've gone through that. Next. So if you see that in the case of radome, the places where all the ice can form as the aircraft travels through the icing condition. So those places are to be protected. Next. When we do that, there are possibility of having electrical way of removing the ice, or by using the compressed air or air from the engine can be utilized to break the ice. The second part is utilized because the consuming the electrical power is going to be detrimental for operation of the system, as it is going to consume the available power continuously some amount. So we found that very elegant way of doing through the compressed air. However, in the antenna, lot of changes and modification need to be done to see that the compressed air is taken to the places of interest very much. The picture shows how the bird strike test was conducted. While we conduct, what all the damage can come, what the learning that we have gone through. You can see that there are some sort of honeycomb type of things are visible to you for in the broken dome. That shows that we have kept some sort of shielding, aluminum shielding internally. Naturally, that is also going to give rise to a possibility of peeling or possibility of breakage. So we have to do as some other way of design. That was introduced at that point of time to have sort of a shielding effect, but later we have to have some changes in order to ensure shielding as well as withstanding the bird strike. And that has happened, and we could achieve that in the later version. The assembly has to be done in the presence of the foreigners because they go through the complete certification process. The antenna, whatever we do, is getting certified as a body, as a part and parcel of the aircraft, and that has to get certified as a 425 category. So that is the reason their inspectors were present in all the stages, and it was completely certified by a Brazilian agency. Now, ultimately, the antenna we are looking at as an antenna as such, the pattern ought to be looked into. Being an airborne radar, the pattern in 2-dimension is not the only thing is essential. We need to look at it 3-dimensional because apart from the main lobe, entire side lobe structure is going to have a look at the ground, which means there is going to be a lot of clutter is going to come. In addition to that, what we do at testing at the ground has to be evaluated when that is flying at a higher altitude, where the temperature could be lower. Even that is tested and managed. The next part is when we combine both the primary and secondary radar, what are the process through which that we evaluate, and ultimately what we call it as a collimation, and so that the antenna elements behave uniformly and gets you the best possible pattern. Next. Another important study is the antenna, given a chance from the antenna engineers, should be as away from the body possible. That means infinite distance between the body of the aircraft and the antenna. As far as the aerodynamic structural point of view, it has to be probably inside the aircraft itself. Then only it is the best. But we have to come for a compromise. The study conducted and we evolved a very good distance by which that both aeronautical requirement as well as the electrical requirements were just met. These are all some of the tests and trials carried out. One is in Norway, we conducted the trials for the icing conditions. As you can see that without using the icing, equipment, how the ice will be formed, and then we created that, and finally we cleared that. And the other one is highest altitude at Leh. The takeoff and landing was done, and air-to-air refueling is carried out in several times. In addition to that, the emission, that is for protection against the missiles, is also was conducted using a CMDS or a flare from the aircraft. All those tests were trials were conducted. In addition to that, the radar, the other major important system is ESM system. It also have to have self-protection unit and obviously the radar warning receiver. All were combined, and it gives a 360 degrees coverage for the system. This is specifically how the CMDS is controlled by the pilot. As and when he finds a threat, the cockpit monitor shows you what direction threat is there, and the pilot decides on the software or the type of software what to be used for avoiding the threat. That is what is being depicted here. We also said that we have a communication system. In addition to the line of sight communication, We also have what is called satellite communication. So beyond line of sight also it can be covered, and it is all the time coming to the ground. The mission communication system is nothing but talking to the pilots, giving them instruction, and there are 7 radios are there which operate both in VOHF as well as in the HF region. Next. As regards the ground station is concerned, we must have equally powerful ground station, because entire AVAX information is going to get into the IAF node, that is IACCS, and thereby we can transmit and get also the information from various radars. The last but not the least is the ground preparations. We call it mission planning and analysis station, where the entire mission is planned, and when the mission is completed, complete data is analyzed to get full information about the entire process. Next is, for any of this operation to go ahead very well, the operators ought to be trained. We cannot train them all the time on air. So a huge setup is created, creating equivalent to whatever is there in the air. In addition, we also have got a trainer, and he also has got a possibility of introducing the recorded data as well as simulated data, which may or may not come in the entire lifetime. But however, the operator must be trained for those situations. That's how the training station is created. Next. Having done that, all the equipments are very high quality equipments. It may not be possible for us to just test with a very simple methodology or whatever it is. And they are not in hundreds in numbers. So that has to have a very good automated test equipment. Almost entire system can be tested independently or together with this ATE, thereby right at the operator's level itself. That means at the field itself, they can come to know what exactly is the problem and immediately replace and go ahead with their operations, while the part what is being to be repaired or whatever is working wrong can be sent to the laboratory for testing. And this AT is also completed. So having got the complete maintenance and operation, and as well as all the tests completed, as it was told in the beginning in 2017, the first aircraft in the IOC configuration was handed over to the chief in the presence of the Honorable Minister. Having done that, the India is going towards the next generation, which is nothing but the AVAX, which is a bigger version of the exactly what we have done. And it should also cover 360 degrees coverage. Obviously, when I said that 360 degrees coverage, we must have minimum 3 antenna, which cannot be kept as a rectangular on top of the antenna of the aircraft. So naturally, when you have a triangle or any other dimension, square or a triangle, which cannot be carried as it is without a covering dome. So this is the what the design, and for the next generation, next one, the this is the concept design to just indicate you what could be the order of size. A man can stand inside, and all the 4 dimensions, all 4 directions, you will have antennas and as well as the PR module placed, and they all will be cooled with the water. And the next one is the structural, part of the dome will be how it will be. Next. You can see that this is 1/4 or the one side of the antenna itself, completely designed, fabricated, and tested in the indoor test facility. Next one. And the dome completely made 1:1, the final dome, and it's also tested. Having completed it, there is another new program given to the DRDO that is called multi-mission maritime aircraft. This is for the Coast Guard. These are all the programs and projects going on for the last 40 years. Next slide. If you see that from the journey, that is 1978 or so, the E2C got introduced, and 83, that is about 20 years after war published in US, the E3 got introduced, and they're all in operation, and it has gone through various version changes. Presently, I was told it is version D, and it will be utilized even up to 2040. And followed by that, electronic scanning started, or ASA type of radar started with the Saab of Ericsson, and somewhere in 2004 or so it got introduced, and more has got come in the 2010, and we also came into the operation by 2015. Could be completed all our tests and given it to the Air Force for induction in 2017, and we hopefully will be able to complete on the Airbus 330 on the next program, maybe by 2020. So if we see that the ASWAC is the office started for AWACS program in 1985, but it could not proceed after a technical report, stopped in some time. And 1993, the ASP program started. However, it stopped abruptly because of the crash in 1999. In 2007, with the OR finalization, AWNC, we started and we succeeded in inducting it. And hopefully, AWACS India also will go through the process. Fortunately, I have been associated in all the phases, including in the ASP program. Just before the crash, the previous sortie, I myself was flying in that aircraft. Next. So the overall advantage is not only in the procurement cost, but mainly in the maintenance cost. As a matter of fact, when compared to what others have bought in the neighboring country, our system is almost half the cost when compared to whatever the bought out cost, including the complete design and development expenditure. So it is a huge advantage in the initially, more than anything else, in a long-term maintenance, it's going to be much more advantageous, and every possible software and hardware is in our control, we can do wonders. So this is the journey. This is the journey carried out by a group of people in Center for Airborne System, CAPS, of a DRDO, along with various other laboratories of DRDO. In addition, all the other industries, HIL, Bharat Electronics, and other public sectors, in various aspects they were involved. I would like to thank all of them. With this, I would like to conclude. Jai Hind. If you have any question, participants can probably throw some questions. If time permits, I'll answer.
Thank you very much, sir, for a very interesting session, a very informative session for all of us. And I would like to inform you that total number of participants crossed more than 306. None of them left. In fact, they're holded to your session. Sir, there is a Q&A option is there available. I request the HAL representative, please flash Q&A to the distinguished speaker, please.
If you have some one or two questions, I'll answer directly. After that, probably I can see if they have, anybody's having question to ask.
Sir, you would like to take a live question, sir?
I like to do that if possible.
Yeah, it's possible, sir. I am now giving some choice, like some of the participants. Please raise your hands. So Vikram is raised a hand. Neelam. Sir, shall I give a live, sir?
Please.
Yeah. Vikram is on live.
Yes, Vikram.
Vikram, please unmute yourself and ask question.
Yes. Can you hear me?
Yes.
Yes,
Sir, good afternoon to you. It was a wonderful presentation. I'm Vikram representing Larsen & Toubro L&T Strategic Electronics Center, Bangalore. My question is, are there any, could you list out any 3 areas within this segment where you would want industry to contribute?
See, there is no doubt there is industry can contribute in several areas, particularly in the embedded system, as well as a huge amount of software being done. But unfortunately, this is not a run-of-the-mill production item. Presently, the government of India has placed order for 3 AWACS that we have done it, and the third one will be anytime will be handed over. In addition to that, the next version, the bigger version, 6 numbers being ordered. And beyond that, it's not going to be in hundreds. All over the world, the AWACS numbers are going to be less. But the maintenance aspect part of it is going to be a huge effort, and over a period, it can have also an improvement. Like even Americans have done from the first version to now fourth version. So entire hardware inside as well as the software is changed except for the antenna and the transmitter. That's what I was told. So likewise, there could be a lot of possibilities of opportunities existing for us.
Sir, shall I allow one more person also?
Please, if you don't mind.
Yeah, there is a person named RS. I hope you please introduce formally and ask the question. I'm allowing you to ask the question. Mr. RS, you have to enable yourself, unmute yourself.
Am I audible now?
Yes.
Good afternoon, sir. I am Ranadeep Saha from Larsen & Toubro, Mumbai. I work in radar division. I wanted to know, is this phased array radar in AWACS, is it a kind of a multifunction radar wherein simultaneously surveillance, track, and search operation can be done?
Yeah, it is more than a phased array. Phased array normally not necessarily an active array. This is an active array having a TR module at the back, and being an electronically scanned active array, it can do all the surveillance functions as well as additionally simultaneously it can sequentially do the tracking also. However, in the case of surveillance with respect to AWACS, is not meant for any tracking because that is generally handed over to the other system which is going to probably deliver the weapon. That's how it is.
Thank you, sir.
Sir, now one more person is there. Shall I close it or shall I give you one more?
I don't mind one more.
Yeah, Srinivas Kirti, I'm allowing you to talk. Unmute yourself and ask your question.
Can you hear me, sir?
Yes, sir.
Yes. Sir, could you please throw more light on the Okay, I'm a PhD student at Aerospace Department, Indian Institute of Science. I would like to know the operational requirements of multi-mission maritime aircraft that you mentioned.
I thought it is listed there. Basically, it is supposed to do sea surveillance, unlike in the case of AWACS, where we are looking for aircrafts and surveillance we are doing. Here it is for the surface ships and boats and probably any other intrusion need to be checked. It has got another function called in the event of unwanted intruder, we may have to have some gun and other things to prevent them. In addition to that, it has got optical systems to have a closer look, including identifying unwanted tankers coming and unloading unwanted fluids in our territory. And it also has got a laser interferometer and other systems to measure and find out what exactly is the damage due to contaminating oil being spilled by other opponents or not necessarily opponents, even others. So all these features are there. In addition to that, transportation, ambulance service, in the event of some sort of emergency, go and search, all those functionalities are combined in that.
So there are a lot of other people are also wanted to raise questions. I hope, shall I close it, sir?
It's a time is the constraint. I have no problem.
You have no problem, sir. Shall I allow one more person? Mr. Akhil Akash has raised, and many people are actually raising their hands. I'll allow Akhil Akash. Akhil, please unmute yourself and ask your question.
Hello, sir. Can you hear me?
Yes, I'm able to hear you, Akhilesh.
Sir, I'm an architectural student from Planning and Architecture, Vijayawada. So my question is that why fitting onto an aircraft can we go for like satellite, fitting onto the satellite so that we can have like every time an aircraft flies, it is very difficult in wars. It will be detected by enemies also. So why can't it be on satellites, which will also use less amount of electricity also?
Yeah, it is not that it is not there. They are also there. But let's say low orbit satellite is going to revisit every, say, some time. It is not going to be continuously available, unlike a geostationary target or geostationary satellite. Let us take a geostationary satellite which can look at the area of our interest all the time. But then whatever the antenna size you make, look at the beam. By the time it comes and reaches the ground, it will be so huge, you won't be able to know whether it is the aircraft is starting from Pakistan or China or from India. So how do you distinguish? So these are all the complications we have in case we go for a higher and higher range or altitude. At the same time, in case you are using an aircraft, you can probably dwell for even as much as 8 hours, 12 hours and get precisely what you want, and also deploy only when you want. You don't have to deploy all the time. Most of these informations are well predictable, and we can do that surveillance much better way. That's the way it is. So surveillance through air will sustain and will stay for long years to go.
Now, sir, one last participant, Miss Neelam, I'm going to permit you to ask question.
Sure.
Please unmute yourself.
Hi, sir. Neelam Matthews here. This is regarding the A330s. There's no aircraft as yet. So you said by 2020, it would be ready to talk about. And also you spoke about 6 additional AEWs. When was this order given? And what is the deadline for delivery? Thank you.
Madam, you know me, and you know that I'm retired now.
Yes, sir.
So I can only tell what the information I have. But as regards the A330, as per the government's CCS cleared, we have gone through the negotiation, and the final CCS is in the preparation for getting that complete clearance. In the sense, in principle, approval was given for 6 numbers of AWACS. Based on that only, the negotiation for Airbus 330 happened. But the final approval will come. And that's why I said I hope we will be able to do it. Because there is a preliminary project wherein you saw the dome, you saw the antenna, which are the most critical one, which has been done and available within the country, within the lab. We believe rest of the things can go fast, provided we get the sanction fast. And as regards to AWNC, I never said AWNC, I said AWACS, 6 numbers in the pipeline.
Thank you, sir. I'm now closing the question and answer session. There are so many questions also is there in the Q&A section. I hope HAL representatives will pass it on to you for your favorable answer. And we can circulate to all the participants about the question and answers, whatever the questions arise with you.
I will certainly answer. Whether the answer is going to be favorable or not, I don't know. I'll only give what answer I know.
Fair enough, sir. Thank you very much. Sir, just I'm informing the participants, I just flashed a poll to understand the quality of this webinar, not with respect to the webinar content, but with respect to the way we organize the webinar. It will help us to understand if any shortcomings are there, we can able to do better. Please rate the webinar so that we'll improve, and I'll also give you a better webinar from the days to come. So,
I don't mind today giving a feedback on my presentation also. I can improve myself. Thank you.
So fair enough, sir. Thank you very much. Thank you very much. I would like to now ask the ministry representatives, would you like to have any word before closing the webinar? From NEGD studio, I request the Jay sir is present. Yes, sir.
Yes,
please.
Yeah, the talk by Dr. Christopher was very informative and very thought-provoking, and it gave a very good picture of the journey which this project has taken. And I also thank him very much for his presentation, and also thank NEGD for making all the arrangements for this webinar. Thank you very much.
Thank you very much, sir, for giving short and sweet. So now we are able to see the screen of next webinar, which is going to be taking place tomorrow from another eminent speaker, Sri Jitendra Jadhav, from Director CSR NAL. He'll be taking a webinar on regional transport aircraft of India. I request all of you to please take part in the webinar. And these webinars are very informative, very rarely available in the public domain. It will make us to understand the different aspects of the Aero India themes. And also, I would like to share the screen of Aero India website. Please, here you can able to register yourself. Yeah. I will just share you the screen of live portal of Aero India. Yes. This is the live portal of Aero India. I request you to, all of you to note down. You're able to register yourself for the webinars. Please pass on this information to your friends also. This full information about the webinar has been given, and as well as the home So this is available for you to have all the information on Aero India. I'll request all the participants to take note of it, register yourself, and please take part in the webinars. Tomorrow's webinar also. Like this, we have planned many other webinars. So you can take part in the webinars and get yourself enriched with the knowledge which is rarely available in the public domain. With this, I'll thank a few officers. Especially, I would like to thank our President and CEO, NEGD, for giving me an opportunity to host this webinar. Apart from that, we also wanted to thank Dr. Ajay Kumar, Secretary, Department of Defense Production, and also Sri Barun Mitra, sir, both are senior IAS officers and from the Defense Production Ministry Department, for giving us an opportunity to host these webinars through Digital India LMS. With this, we'll conclude. Thank you very much, and thank you very much for taking part in this webinar, all of you participants. With this, we'll close. Thank you.